So this is the first question of the third assignment regarding the deck of cards. So initially we are creating the object for this deck. So here we are creating the object. Initially here we have taken this variable that is list sorted. This is used to find whether the list is sorted or not. So initially we are assigning the value as false to this, and then whenever we are in this in a constructor, we are making this as true, because here we are appending the cards in the sorted manner. So the range goes from 1 to 14, that is sorted, and then this suits that we'll be taking from this list, that is also in sorted manner. So initially whenever we create the object, the list will be in sorted manner. Okay, then here we are whenever we are getting these cards, we are we are mapping the index to the card. That means this is used for searching. This will cover later. So here this function we need to complete, so that here what we are doing is initially we have to print like the number of cards. uh, so here the 0 will be the size of the cards, and that means the 51 52. So here the at this here this format will give this sorted or shuffled. If this function, if this variable, that is list sorted, if it is true, then we'll be getting sorted here, and if it is false, then we'll be getting shuffled in this placeholder. So this function has to be completed, that is done. And then this is the other property, that is sorted. So this also we need to complete. So what it is doing is, it is simply returning that is sorted list, the variable which you have created here. This variable will be holding the sorted, whether the list is sorted or not. Okay, so this variable we are setting whenever we are calling this sort method. Whenever the list is getting sorted, we are making it true, and whenever we are calling this method shuffle, so we are setting this is list sorted as false. So this variable will be having the current state, whether the list is sorted or not. So here whenever we call this function is sorted, this property is used. Whenever this property is called, we'll be returning this is list sorted value. Okay, and then this is the sort method. So here we are using bubble sort to sort the cards, and then we are calling this map index to card method to for this is helpful for searching in a constant time. Now this will discuss when we discuss the search method. And then here the shuffle, and then here this shuffle we are just making this list as list is sorted or not as false. And then again we'll be calling this map index to card. So and then we'll be returning this shuffled deck of cards. This is the given method anyway. So here this method was we have to complete it. So here initially this card variable will be having the description of the card that we'll be taking from the user. Okay, so here we are asking the user the suit of the card, and then we are asking the user to enter the number of the card. So once we get the description of the card, we are returning the card from this describe card method, and then we'll be getting that particular card description in this variable card. So now here we are getting this index from this card index map. This is actually a dictionary. So here with the help of this card, we are getting the index at which this particular card is present. Okay, so this dictionary we are creating, and then here we are yeah, here map index to card. So here what we are doing is, if first of all we are clearing whatever the mapping we have done earlier. So now the I ranges from 0 to the size of the deck of cards. Okay, so now the deck of card means the card, the description, whatever the description of the card is there, that is the key, and to that key we are assigning this particular index from 0 to the size of the card. So all the cards will be if the first card will be the 0 index, and the last card will be the 51 index. So this we are mapping here. So this is useful for searching of the card in constant time. Okay, so since we are mapping this indices to this card, so now here we can, with the help of this card description, we can get the index of the card from this map, from this dictionary. Okay, and then we'll be printing out the so and so card, whichever the user has described is present at so and so index. This is one. This will be printed index here. Okay, so this is the search method. Okay, and here we have added this three methods. This is for the representing of the card object. So here basically we are just returning this string, whatever this here how we are representing the string means the value of the card and then the suit. For example, like if we have ace of diamonds, this is how it will be printed out whenever we use it. And then hash, this is done for this mapping of the cards. Then greater than is actually we are using this function of this method for comparing two cards at the time of sorting. So that's why we are overriding this greater than method. So basically, first of all, will be if the suit is different, then we'll be comparing the suit, and then we'll be comparing the if the suit is different, then we'll be returning if the suit name, whichever is the greater one. First, we'll be comparing the suit name if the suit name is different. If the suit name is same, then we'll be comparing the value. That's it. And then whatever the result will be there, that we'll be returning it here at the time of this bubble sort. Here, yeah, this space will be using it. So this bubble sort will be getting that sorted list of cards. Okay, so now here initially we are creating this object of deck of cards, and then we are printing it out whatever the cards we are having, and then we are shuffling the cards, and then we are printing out the shuffled cards, and then again we are sorting the cards, and then we are printing out the sorted cards, and then we are searching for any card which we want from the list. Okay, now let's run the program and check. Okay, so initially, see, this is the initial initialization of the cards. That is ace of diamonds till this king of spades. So this is initially in the sorted manner, and then we are shuffling it. The shuffled is still here. So the seven of clubs and two of clubs, 10 of clubs, and jack of spades. So this is the shuffled cards, and then again we are sorting out sorting these cards here. So it will be starting from ace of diamonds and going till king of spades. So first diamonds will be printed this 1, 2, 3, 4, 5, 6, and all this thing. Then 10 after 10 we'll be having jack, and then queen, then king, and then again ace of clubs here it will be starting. So first diamonds, then clubs, then hearts, and then spades. Okay, so now here we have to if we want to search any card. So initially we are asking the which suit we need to search. We can give like for example spades, and then the number we can give as 13. Yeah, so king of spades is present at index 51. That is the last one, the 51. That is the size of this card will be 52. So since the indexes start from 0, the last will be 51. Okay, thank you. So this is the second question of third assignment regarding the tree. So here in the given file, first we are creating the object of tree. That is this class we already have the given one. So now then we are reading this random numbers.csv file which was provided, and then we are adding all the elements, this comma separated values present in this CSV file to this tree. We are inserting every element to this tree. So, and after inserting this, insert method is also the given method here, which we already have. So we'll be creating the node, and if we don't have any root node, we'll be assigning that node as a root node. And if we have it, we'll be assigning that given the new data to that child node, either on the left side or the right side. So here, so we are creating the tree, and once the tree is created, we are calculating the leaves and the height of the tree. So for calculating the number of leaves present in that tree, we are using breadth first traversal. So here this breadth first traversal, which is also a given file. So basically this method was used to go through all the nodes present in the tree. So now what we have done few modifications to count the leaves. So basically we have added a variable leaf which will be storing the number of leaves present, and then since we are going through each and every node, so whenever we encounter any node in which we don't have the right child as well as the left child, if both are none, in that case we are incrementing this leaf variable. That means that is a leaf since it is not having any child. So in this while loop, we'll be going through all the nodes in the tree, and whichever node is not having any child, that means it is a leaf, and we are incrementing the value of this leaf. So once we get out of this while loop, we'll be returning the number of leaves present. Okay, and then the returned value will be stored in this leaves variable. And then to calculate the height, we are using this pre-order traversal. So which is here. So in this also we have made some changes to get the height of the tree. So basically what we are doing is the current is none, whatever the node we are passing, if it is none, in that case we are returning 0. Else we'll be returning the max value of the left and the right plus 1. This plus 1 is required for the root node basically. So the left will be going through with this recursive approach, we'll be going through each and every node in the left as well as the right. So the height will be calculated with like whichever is the maximum of this left and the right. So the height of the left side of the tree will be stored in this left variable, and then the right will be stored in this, the height of the right side of the tree will be stored in this right variable. So whichever is the maximum of these two will be returning that plus 1. So once we get the value from here, we'll be putting it into this height variable, and then we are printing out this height of the tree and the leaves present in the tree. Okay, now let's run the program and see here. So we are printing out all the values that is present in the CSV file, and then here we are printing this height and the number of leaves present. The height is 14 and the leaves is 31. Thank you.